This is the third video related to the sample question paper of 2024-2025. Before I start getting into the section C, definitely check out the remaining sections in the playlist. And not just that, after I finish all the sections, I will for sure have a video which compiles all of them into one video. Also, if you found this video helpful, definitely, let me know, and that you can let me know by dropping a comment or dropping a like. That definitely boosts my confidence and lets me know that you actually enjoyed the video. So in this video, we're going to specifically be talking about section C. This section contains 7 questions with an internal choice and 1 question. So they're all short answer type questions and they carry 3 marks each. So we're going to start with question number 22. Write down the reaction occurring on 2 inert electrodes when electrolysis of copper chloride is done. What will happen if a concentrated solution of copper sulfate is replaced with copper chloride? So from what the solution looks like in your in the marking scheme, it seems like all they care about is what has happened to the electrolysis or the products of electrolysis when you have copper chloride and the product of electrolysis of copper sulfate. The thing is, for copper chloride, whatever they've given over here is absolutely right. That's exactly what we expect. We expect to see cathode having a reduction taking place. The copper ion gets reduced, and anode, you'll have oxidation of chlorine, and then it leads to the release of chlorine gas. The issue I have with the answer over here, and for sure you can let me know if you think my thought process is incorrect, but I think the SO42 minus giving rise to or undergoing oxidation is incorrect. First of all, sulfate, for the sulfate ion, sulfur is in its maximum oxidation number in the sulfate ion. This means that it cannot further undergo oxidation that easily, right? So let's say, for example, here they've also said that we're talking about a concentrated solution. So even if there is a concentrated solution, it means that it's going to have some amount of, and again, this is what I understood. What I understood was that the solution is made of water and copper sulfate, right? So that means even then there is some amount of water, and the reaction in anode for this particular thing is going to be 2H2O gives rise to O2 plus 4H plus 4 electrons. And this is especially based on the fact that sulfate ion does not like undergoing oxidation. Okay, now if let's say we have a different solvent, I found online that copper sulfate can dissolve to an extent in methanol. Even when that happens, the methanol itself is going to undergo the oxidation reaction, leading to different byproducts even before the sulfate ion. Again, if you have an idea as to why this might be incorrect, definitely let me know. But according to me, in the anode, the reaction is going to be for the water molecule. Okay, now the next, and this was from the chapter electrochemistry. The second question under this is write an expression, and it's 2 marks, right? So you have, write an expression for the molar conductivity of aluminium sulfate at infinite dilution according to Kohlsch's law. So according to this, you have the dissociation is given by V plus for cations, V minus, so you have lambda naught M equals to V plus lambda naught plus V minus. So essentially using this equation, we're able to get to this place. Now, obviously Al2SO4, so aluminium sulfate, I hope at this point you know how to do the crisscross method and get the formula. And basically you are having to add the number of atoms in the front, or in this case of sulfate, the number of ions. But basically you have to add that to include that in the equation itself. And obviously this is also from the chapter electrochemistry. It's under variation of conductivity and molar conductivity with concentration. Okay, now the next question, question number 23. Account for the following, and we have 3 give the reasons why, and each of them is 1 mark each. So the lowest oxidation transition metal is basic and the highest is acidic. So obviously, since the word transition metal has come up, we're going to assume safely that it's from the chapter D and F block. And by the way, this is actually a textbook exercise question, 8.25, the first part. This is the same question. So they've given you the exact same question that is in your textbook. Honestly, I wish I'd known a lot more things than I did. Than I do right now when I was in my 12th class. So basically, the lowest oxidation of the transition metal is basic, and then when you have a higher, as the oxidation goes up, you have a more acidic nature. Now, this is because in lower oxides, there are some electrons which are in the valence shell, and these electrons don't like taking part in the formation of bonds. So they like to give those electrons away. They don't want it anymore, and that's why they act as a base. Now, for higher oxides, they don't have enough electrons in the electronic shell, and because of that, there's not enough for donation. They can't give it away as freely, and because of that, they act as acids. So that's related to the ability of donation of electrons in lower oxidation state versus higher oxidation state. And this is under the oxides and oxanions of metals. It actually gives you the example, but it never tells you why. I think they have assumed that because this is one of the questions that's asked in the textbook back questions, you should know. And I hope you do. So the next question. Chromium is a hard metal while mercury is a liquid metal. We obviously know mercury is the only liquid metal. And the reason a chromium is a hard metal is because of something called as interatomic metallic bonding. So there is a metallic bonding in between the atoms, and this is mainly, okay, let me do this. Hang on. Okay, so this, first of all, let's look at the electronic configurations of chromium, which is Cr, Ar, which is argon, 3d5, 4s1. Okay, now on the other hand, mercury is Ar again. Oh, sorry, different line. I'm so sorry. Oops. Just control Z this. Okay. Xenon, 3D, oh, control Z again, 4F14, 5D10, 6S2. So difference between these two, one very important difference is the fact that this has unpaired electrons, this does not. So mercury does not have unpaired electrons, and because of that, it does not form the interatomic metallic bonds. However, chromium has that, and because of the formation of interatomic metallic bonds, it is a hard metal, while mercury is a liquid metal. And that's what is the reason given over here as well. Or that is the reason given over here as well. I'm so sorry. Okay. Now the last question. The ionization energy of elements of the 3D series does not vary that much with increasing the atomic number. Now for all our, till now, whenever we've talked about the periodic table, the one thing that has been consistent is the fact that when you have an increase in atomic number, the ionization energy also changes. But the ionization energy for the 3D series does not vary much. This is because when you have an increase in the electrons, what happens is we've understood the 4s and 3D orbitals are closer in energy. And because they're closer in energy, what happens is when you have increase in the number of electrons, basically the increase is going to be balanced because of the shielding effect. So the 3D orbitals, what they're going to do is they're going to make sure that the nuclear charge doesn't get as strongly or doesn't affect the 4s as strongly as it would. Okay, and because of that, you will have an issue in terms of the increase in nuclear charge is actually counterbalanced by the shielding effect. And because of this, the ionization enthalpy, you observe an irregular trend. Okay, I apologize. It's been a long day, and I don't know if you've noticed, but yeah. Okay, question number 24. So as long as you mention the fact that the increase in effective nuclear charge is counterbalanced by the shielding effect, you should be good to go. Okay, and all of these were from the chapter DNF block elements. The last question was from ionization enthalpies. Okay, the next question we have over here. Give the chemical reaction involved when para-nitrotoluene undergoes ETAR reaction. Now, ETAR reaction is a named reaction, and you should be knowing all the named reactions by now. And I hope you do. If not, I do have a series where I have all the named reactions in one place. So definitely check that out. And each reaction has its own video. So you can, pick and choose whichever you want to learn. I would recommend learning everything just to be safe. But give the chemical reaction involved when para-nitrotoluene undergoes ETAR reaction. Now, this is one of the preparation methods of aldehydes from hydrocarbons, specifically by oxidation of methyl benzene. So you have here, you have we have toluene, but when you have nitrotoluene, the only thing different is going to be having having a nitro group in the para position, which just means that you're going to have an NO2 group over here. Okay, that's going to be the same over here as well, but basically you're going to get, this is one of the preparation method of benzene using chromyl chloride, and that leads to this reaction being called as ETAR reaction. Okay, so that's the first one, and that's exactly what's been given here as well. The next question you have over here is, why does benzoic acid exist as a dimer in an aprotic solvent? Now, again, this is related to the chapter aldehydes, ketones, and carboxylic acids. It's specifically about the physical properties of carboxylic acids. So carboxylic acids like to stay in a dimer state in an aprotic solvent because of intermolecular hydrogen bonding. Intermolecular hydrogen bonding exists between two different molecules, and in this case, if you see, you have an intermolecular hydrogen bond between this O and the H, and then another H and O. Because of this, it likes to stay as a dimer, and it's enjoying that. So as long as you mention the fact that it undergoes intermolecular hydrogen bonding, you should be good to go. The next one is benzene on reaction with methyl chloride in the presence of anhydrous AlCl3 forms toluene. What is the expected outcome if benzene is replaced by benzoic acid? Give the reaction. Give the reason for your answer. Not the reaction, the reason. So basically, one of this is benzene on reaction with methyl chloride. If you remember, this is actually Friedel-Crafts reaction. However, Friedel-Crafts reaction, the carboxyl group does not, or aromatic carboxylic acids undergo electrophilic substitution reaction in which the carboxylic group acts as a deactivating and meta-directing group. They do not undergo Friedel-Crafts reaction because of carboxyl group being ring deactivating, and the catalyst aluminum chloride bonds with the carboxyl group. Because of these two reasons, it does not undergo Friedel-Crafts reaction. So as long as you mention these two reasons, you should be fine. Okay, and I'm pretty sure Friedel-Crafts reaction is in the chapter haloalkanes and haloarenes. If I'm not wrong, it's one of the preparation methods of haloarenes. Again, you can for sure correct me. It's perfectly fine. Okay, question. So this particular question has an internal choice. So an organic compound X does not undergo aldol condensation. However, X with compound Y in the presence of a strong base reacts to give the compound 1,3-diphenyl-prop-2-ene-1-one. First of all, the first thing that you realize over here is that it's not undergoing aldol condensation. Okay, you should know by this point, again, another named reaction. So an aldol condensation is between two carbonyl groups, right? So the product so we need to figure out what X and Y are. Okay, now the product that we have over here, 1,3-diphenyl-prop-2-ene-1-one, is basically, let's draw the structure of that. And that's what I would recommend. If you are stuck in something, definitely just try and see if you can draw the structure of the final product, you might find something that you could use to answer the question. So you have CO, okay, CH, double bond CH, and another benzene. Okay, now here, so essentially you have X with compound Y is reacting in the presence of a strong base to react to give a compound this. So this is essentially the cross aldol condensation. Now, if X is not undergoing aldol condensation, it means it does not have an alpha hydrogen. That is one very important thing we are learning from this. So X does not have the alpha hydrogen, whereas Y has the alpha hydrogen. Because of that, it's able to undergo cross aldol condensation. So by just drawing a straight line, so you have a breakage of this particular bond. So your products are going to be, and this like retrosynthesis product is going to be, you have benzene with CO, CH3, okay, and then you'll have benzene, CO, H. Okay, so it's obvious one of these doesn't have the alpha hydrogen, which is this guy, and this is going to be X and this is going to be Y. Interestingly, under the concept of cross-aldol condensation, this exact reaction is given in your textbooks. So you have benzaldehyde and acetophenone undergoing the cross-aldol condensation to give us this particular product. And so, we needed to identify X and Y, and that's exactly what we did. Chemical reaction involved, you're going to have to write this reaction, and chemical test to distinguish. So essentially we have to distinguish an aldehyde and a ketone. So the way we do that is by the tolerance test. So when we warm it in ammoniacal silver nitrate, so basically it's the silver, it causes the color of or it forms a mirror inside the test tube. Actually, it's pretty cool. I've done it. But basically, the tolerance reagent, benzaldehyde, will give us a product. However, the acetophenone does not react with tolerance reagent. And because of that, and that's how we are able to distinguish between the two. Question number 25. Give the structure of all the possible dipeptides formed when the following two amino acids form a peptide bond. So we have alanine and glycine. Both of these you basically under, that's, that the previous question was, the second part of previous question was also based on aldehydes, ketones, and carboxylic acids. So this question number 25, is obviously based on the chapter biomolecules. So we have something called as peptide linkages, which are formed by the loss of water, and the CONH is the peptide linkage. So you have two possibilities where you have the COOH from the glycine and NH2 from alanine and NH2 from glycine, or it could be the other way around where you have this, and that's how your the marking scheme has given us, where we have glycine and alanine, and then you have it the other way around where you have alanine and glycine, excuse me. Okay, so that's all. We just have to remove a water molecule and you should be able to easily write the reaction or write the formula or the structure of the final peptide bond. Okay. The next question. Keratin, insulin, and myosin are few examples of proteins present in the human body. Identify which type of protein is keratin and insulin and differentiate between them based on their physical properties. Now, this is based on the next topic under the structure of proteins. You have a classification of proteins into fibrous and globular proteins. So, you have the example of fibrous protein is keratin, and the important thing is that they run parallel to each other and they're held together by hydrogen and disulfide bonds. Okay, so that's one structural difference. On the other hand, globular proteins, the example we have over here is insulin and albumin, but basically the structure, the the chains of polypeptides, they're coiling around each other, which gives them a spherical shape. That's why you call them globular proteins. Obviously, they're further divided, but as long as you mention what kind of protein each of these questions are and how they are different, you should be good to go. And this is also from the chapter Biomolecules. The next question we have over here is question number 26. Neeta was experimenting in the lab to study the chemical activity or chemical reactivity of alcohols. She carried out dehydration reaction of propanol at 140 Celsius to 180 Celsius. Different products were obtained at these two temperatures. Now we need to identify the major product at 140 and the mechanism. And we have to identify the major product at 180. Now, if you are really questioning if you know the answer to this question, what I would recommend is just switching from Celsius to Kelvin. So once you switch it to Kelvin, it's one of the preparation methods that we use for the preparation of ethers. Okay, now this is under the chapter alcohols, phenols and ethers. And by dehydration of alcohols, we are able to prepare ethers, but at different temperatures, you have different products. Okay, at a lower temperature, you have the formation of the ether, right? And this is formed by the SN2 reaction. Okay, so you would just have to mention that the diethyl ether is the product, and the mechanism that leads to the formation of diethyl ether is the nucleophilic or SN2 bimolecular reaction. Oh my god, nucleophilic bimolecular reaction. Okay, and if I said substitution, I apologize. It's nuclear bimolecular reaction. We need to mention that. And then identify the major product at 180 Celsius. In this case, because at a high temperature, it undergoes the process of elimination. So it undergoes E1 elimination actually. And so it leads to the formation of CH2. So you just need to mention what the product is, ethene and diethyl ether, and you should be perfect. All right, now the next question you have over here is various isomeric haloalkanes with the general formula C4H9Cl undergo hydrolysis reaction. Among them, compound A is the most reactive through SN1 mechanism. Identify A citing the reason for your choice. Write the mechanism for the reaction. So obviously it's from the chapter haloalkanes and haloarenes, and the moment you have which mechanism, SN1, why is it undergoing SN1? It's obviously nucleophilic substitution reactions, right? So based on the formula, it's obvious that the compound given to us is 2-bromo-2-methyl propane. That is because not just the formula, also the fact that it undergoes SN1 reactions. SN1 reactions are predominantly, we know that tertiary alkyl halides prefer to undergo SN1 reactions, and I'm sure you know why and what's the preference, all of that. But if you do not, definitely check out the video I have related to nucleophilic substitution reaction. I talk about it for an hour, so I hope that helps. And this is from I did mention that it was from haloalkanes and haloarenes. So basically you just have to mention the mechanism. So and the reason we have this undergoing SN1 reaction is because the carbocation that is formed is stable, and this is because of a particular effect because of the alkyl groups. And definitely comment what the effect is below. You do remember, like inductive effect, mesomeric, all of those. One of those effects is causing this. Definitely let me know in the comments below. So that's all. You just need to mention the mechanism and you should be fine. The last question under section C. So we've been given a reaction over here. Okay, and we've also been given the equilibrium constant. Now, the moment I saw this, I was like, hang on, you guys don't have equilibrium in class 12. But this is related to the chapter electrochemistry because we need to calculate the standard EMF of the cell. Now, we've also been very conveniently given the value of log. So that obviously means we need the value of log in our equations, right? So basically, according to the relationship between E naught cell and the value of Kc, the equilibrium constant, this is the final relationship that we get, and this is from your textbooks. However, at 25 Celsius, you have at 298 Kelvin, you have E naught cell is 0.0591 log Kc by m. Now, one very important thing I wanted to point out over here was that because the number of electrons are not the same in both cases, we would have had to multiply it with this into 3 and this into 6. Okay, and that's how, this into 2. So your final balanced equation is going to be 3SN4 and then 6 electrons and then 3SN2, and then this is going to be 2, 2, and this is going to be 6. Okay, so your final equation is 3SN4 plus 2Al gives rise to 3SN2 plus 2Al3 plus. But the more important thing is the fact that there are 6 electrons. So the value of N over here is going to be 6. Okay, so you just have to substitute it and you'll have to solve the equations to get to the value of E naught cell. And notice they started with 0.0591, and then the next equation you can just ignore the one and just do 0.059 and you should be fine. Okay, so you're getting the value of the E naught cell, and we know, and the next question is what will be the E naught cell if the half cell if E naught of half cell is so and so. So we've been given the value of one of them. We just need to figure out the value of E naught cell of the other. We're using this particular equation where E naught equals to E naught R minus E naught left, or you could also think about it as E naught cathode minus E naught anode. So you have Sn minus Al, 3 plus Al. Okay, so with that, we're done with section C. In the next video, we will be doing section D. And definitely let me know if you found this helpful. And I'll see you in 2 days.